Hi, my name is David, and I try to play guitar. I'm not very good, as you can tell. One day, I saw a video of blues great Joe Bonamassa getting very technical about his guitar amplifiers. For a guitar player, that guy really knows his stuff about amps. He inspired me to learn more. But to really understand guitar amps, you need to take them apart and put them back together. I watched hundreds of videos. I read all kinds of books. From Craigslist and eBay, I bought a used soldering iron, some old voltmeters, an ancient oscilloscope, and other test gear. Eventually, I built an entire electronics lab. Now, I guess I'm sort of an amp mechanic. I fix other electronics too, and this is my journey. I figured I'd share so others can learn too. I hope you like it, and just as a disclaimer, be sure to consult an expert before working with electricity.
Hi, Dave the Amp Mechanic coming to you from my amp lab in Boston, Massachusetts, and here with another guitar amplifier repair. This time it's a Mesa Boogie DC-3. Now, Mesa Boogies are legendary. They're great amps, and typically they're engineered so well that they don't always go bad. Why would one need a repair? Well, my friend Greg brought this amplifier to me and he said, hey look, when I fire this up, plug my guitar into it, the sounds pretty good at the beginning, but then all of a sudden it drops out. Something's going wrong. So we threw the amp on the amp bench here to take a good look at it, fired it up to see if I could reproduce the problem, and the first thing I noticed was that one of the tubes, the output tubes, the EL84 output tubes, was red plating. So that was a big red flag right there, literally, and I immediately powered the amp down, let the tubes cool off, and pulled the tubes out. Well, that's where I discovered the first problem. And it's a good lesson to all of you who own amplifiers or repair them, is how important it is to have a matched set of tubes in your amp. So in this case, I pulled the tubes out, after they cooled off, of course, and the first thing I noticed was that it was not a matched set of tubes. Now, how did I know that? Well, because the tubes were actually from different manufacturers. It was nearly impossible for them to be a matched set. So sure enough, I checked with the owner to find out why the tubes were changed and why there was an unmatched set in the amplifier. And this is when he told me, well, there was also a reverb problem with the amp, and he wasn't sure what was going on there. And so one of the first instincts of anybody who owns a guitar amplifier sometimes is just change the tubes, see what happens. Maybe that'll make the problem go away. And that was just a natural response, right, to fix the problem. If you've got a problem, it's a tube amp, replace the tubes. Maybe that'll fix it, maybe it won't. But because unmatched tubes went into the amp, that created a new problem. Once I got the old tubes back into the amp, we eliminated the original problem, which is the sound dropping out. But now we're back to the reverb problem. And one note about the DC-3 Mesa Boogie amp and all Mesa Boogie amps. In the case of Mesa Boogie amps, the designer of those amps, the founder of the company, it's a feat of engineering, quite frankly. Those amps are engineered to be amazing amplifiers. What they do, though, is they push the tubes, the output tubes, to their very limit. And this is why matching tubes is so important in the case of the Mesa Boogies. Not only must the tubes match, but they also must be matched and pre-tested to run in a Mesa Boogie amp. Now that's unusual because most of the times you just go out and buy a matched set of output tubes and you put them in your amp and you're good to go. Not with Mesa Boogies. And the reason is because they run their tubes super hot. The amps are engineered to really run the tubes actually above their limit. And I ran some tests to see, like, you know, how many volts we're getting. For example, on the plate, it's like 400 volts, where you almost never see that on an EL84 in an amplifier. And the reason the tubes have to be matched, and this is a theory, but I'm pretty sure I'm right about this, is that when they're looking for tubes to run in a Mesa Boogie amp, a matched set, they're looking for tubes that kind of run at the cooler end of the range. That way there's a little more tolerance to push them and run them really hot. So this way, at the end of the day, you still get something that's reasonable in terms of plate dissipation across all of your tubes. They're kind of well matched, right? But they're not, because you're running them at 400 volts, you're not pushing them to the limit, they just blow up. So that's why when you order tubes, a matched set of tubes to go into a Mesa Boogie, it's very important to make sure that you buy tubes that have been matched and certified to run in a Mesa Boogie amp. One of the best places to get those, of course, is from Mesa Boogie themselves. The other thing to know about the tubes and the way it's set up is an AmpMechanic like me might naturally go in there and say, oh wow, these are running really hot, let's bias it down, or let's adjust the bias, or let's, there's one bias resistor across 4 output tubes, so let's, throw some extra resistors and match, 1 resistor per tube or something like that, so that you can individually control the bias. But if you go on the website and you look at what the founder has written, he is like, you should never, ever, ever have to bias an amp. So that's the way the Mesa Boogies are designed. The Mesa Boogies are designed to be sort of trouble-free. You should never have to bias them, but in order to get that sort of operating condition out of them, you have to have a matched set of tubes that have been certified to run in Mesa Boogies. And so, of course, when I got the tubes that he originally had in the amplifier back, it seemed to work pretty well, right? So then it was back to the reverb problem. Like, why were we having a reverb problem? So we're going to go and see how that turned out. We're going to start to look at the reverb tank. But before we do that, I just want to make one note. When I had the amp up and running, I was noticing that we would get some volume on the amp, and I would hear something, and then all of a sudden the sound would just drop out completely, like just by fiddling with the volume control. And I try to rock the volume control back and forth, and one second it would be super loud, and the next second it would be very faint. Which of course means that there's some sort of continuity problem in the pot itself, like the volume adjustment pot. And what you're going to find out as I go through the rest of this repair is there's a little bit of a pattern here with this amplifier, and the problem was actually kind of solved after I went back to the owner and I said, where has this amp been? All right, let's go take a look at the reverb tank and see what's going on there.
Okay, so we've got the back doors off of this Mesa Boogie DC-3 amplifier, and before we get to work on it, we're just going to inspect the interior. And you can see that really nice speaker here, Celestion G12. It's an 8 ohm speaker, vintage 30. Nice speaker. Solderings are pretty solid here. I always check those out. And one thing I like about the construction of this amp is it's got this nice little pouch with a Velcro flap on it. And that's where you keep your spare tubes. So when you're gigging with an amp like this and you blow a tube, which you could easily do because of how hot these amps run, you want to keep your spare tubes with you. Of course, with this amplifier, it's super important that the tubes you have are matching tubes and they're designed for this particular amplifier. In other words, they've been selected specifically to run in a Mesa Boogie DC-3 because of how hard these amps push the tubes. Now, looking here, we want to figure out what's wrong with the reverb, and but before I do that, you just want to check the reverb tank, and it's kind of it's nicely mounted here. There's some rubber grommets around that insulate the reverb tank from any vibrations in the cabinet. You always want to see that. One thing I am noticing is as we look back in here, you can see that some little critter was probably in this amp, maybe like a mouse or something. Looks like a shelled acorn back in the corner there. So not that that would have impacted the reverb, but before we put this amp back together, we'll certainly clean it up. Now, one of the things I always do before doing any work on an amp like this is I go to the manufacturer's website just to see if they have any advice in the event that something's not working correctly. It's always a good idea to do that. And sure enough, the Mesa Boogie website actually has a great little page on testing a reverb tank with your digital multimeter. So we're going to do exactly what it says to do, and here's how we're going to do it. It says to go ahead and disconnect your cables from the chassis. We already have the chassis out of this amp, and get your multimeter set up to read resistance. So we're going to do that. And instead of having it on auto range, right now it's looking at mega ohms, we'll range it down to
regular ohms. And right now the line is open, as you can see. I've got my leads set up here, and we'll just kind of see if we get some continuity there. There we go. We got a little bit of resistance in the wire, in the leads. And it tells me what to do when it comes to connecting and testing up these guys, the leads coming off of the tank. Now, just to go over what we have here, we have one shielded wire, excuse me, and we have one unshielded wire. And these are your typical RCA jacks. And so on this unshielded wire, really nothing is connected to the shield portion, only to the tip. And we'll probably be connecting between them. So let's see what it says you should do. Okay, for the first test, what the website says to do is check the resistance between the shield and the tip of the output wire. So let's go ahead and do that. We'll hook up one lead here to the shield and another lead to the tip, and let's see what we get here. And it says we should get about 200 ohms. So let's see what it says. And look at that. It's pretty much spot on. Wow. 200.2 ohms. So that checks out right now. The next test we need to do is we need to see whether or not there is any resistance between the shield of the return cable and the tip of the input cable. So let's go ahead and try that one. And in this case, we should see almost no resistance. It's saying maybe about 1 ohm. So let's go ahead and move from the tip of the output, and we're going to the tip of the input cable. And in this case, we should see somewhere about 1 ohm. And as you can see, we're looking at an open line. In other words, there is no connection here. And so that to me would suggest that we have a serious problem. It says right here, if either point reads open, the tank is at fault. So we definitely are looking like we have a problem with the tank, which means now I'm going to have to pull the tank out. Okay, to pull the tank out, we'll get the speaker wire out of the way here. Just stick it up out of the way. And the first thing I'll do is I'll just, well, I don't even know if I need to disconnect those wires yet, but using my trusty old garage sale electric screwdriver here. Okay, that's not going to work because it doesn't fit in there because of the lip, so I probably need a bigger little Phillips head shaft to go on that, the bit. So let's go ahead and we'll take these out by hand. Okay. And we want to keep track of the rubber grommets because once we put it back together, okay, it doesn't, we don't want to, now there should be another screw just like this one on the other side, and there is. You can't really see it that easily. Okay, there's the last one, and then should be one somewhere around here, and there it is. So let's go ahead and get that one out. And now these Reverb tanks are bare underneath, so you can see right into them. Now what I have to do is I have to be careful because the wires are attached here and I don't want them. So the first thing I'll do is I'll look to disconnect these wires without stressing them out. There's all sorts of spider webs here. Okay, that doesn't want to come, so what we're going to do is we're just going to take this wire this one off here. That way the whole thing just comes out. And because I don't want to stress the wires too much. Now what I do with these little screws is I always take these, I save these things from prescriptions and stuff for me and my kids, and I always put the screws into them so I don't lose that. So now let's see what we got here. And there's the reverb tank. The magnet is pulling on it. So the next thing we'll do, whoops, let's stop that. We will we'll do some tests on the tank to see what could be wrong with it, and whether or not we can fix it or we have to replace it. Okay, so I've got the tank out here, and I've got my multimeter sitting across the top of it. And while the tank is out, now I can work on it kind of by itself, not kind of fiddling around with it in the back of the amp. And the first thing I want to do is just rerun the tests that we ran. So for starters, let's go ahead and run the test where I was going from the tip of the output lead, the output wire, to the shield of the output wire, and I believe they said we should get about 200 ohms, and that looks pretty good. Okay, so next we want to go from the tip of the shield, the unshielded input wire, to the sleeve of the other wire. And so remember when in the amp I was getting an open line, now I'm getting 41 ohms, which is kind of weird. So my next test that I'll do here is to double check the continuity of the cables. Maybe it's the cable that's wrong. So let's take the cable out. That should open the line up. And now let's check the continuity to of just the sleeve part. That should be a very low ohm rating, 0.5, and it is. Now let's move it over to the tip part and see what we get on the tip. Very low ohm rating. So those two things work. I'll reconnect this back up here, and let's try the same. If I can get it off, I can't even get it off. So let's see. I'm going to double check. I'll poke inside here to the little assembly. So let's check the continuity from the tip of the unshielded input, and then we'll go to the tip here, right there, because that's the tip. And there we have a low ohms rating. And now let's just double check if there's any continuity on the shield. I would suspect not, because remember, there's nothing here. Okay, so that's the way it's supposed to be. There's no connection. When you look at this particular, when you're looking at this here, you don't get any connection of the wire, the lead, to the shield itself. This is an unshielded connection. So let's go back to the continuity test, going from the one end of the reverb tank to the other. And again, that was connecting the one of the digital multimeter leads to the shield of the output, to the tip of the input. Okay, and now we're seeing 221. This is what has got me confused. Now I thought maybe it had something to do with the solderings on the back side here, and I noticed that when I play around with this, it jumps around a little bit. So now I'm going to jiggle. Aha.
I'm playing with the jack here, and as you can see, it is all over the map. I don't think it's the wire. I think it's something in the jack here that has gone wrong. So let's just kind of unplug it again and take a look there. I don't know if we can see anything visually there. Some dust. You know, what I'm going to do is that tip, the sleeve side, looks very badly oxidized. Or something. There's something on there. So what I'm going to do is I'm going to polish that up, and then we'll come back and we'll try it again. Alrighty, so here we are. We're looking at the Reverb tank, and I was talking to you a little bit about polishing up the RCA jacks, right? So, you know, here's this one RCA jack, and as you can see, and hopefully the autofocus can get in on that, but it's pretty well oxidized right there, all the way around. And the same is, you know, was true of this, and I started to polish this. Now, a lot of amp mechanics, their natural instinct will be to try to throw some sort of deoxit on here, the same stuff that you use like in tube sockets and things to clean that up. But when I threw the deoxit on here, it really wasn't doing a very good job. Now, those of you who have had model trains when you're a kid, you might remember that every now and then the tracks would get really oxidized and your locomotive would just kind of come to a complete stop when you hit those oxidized portions of the track. And the way to clean that, I remember from being a kid, is to get an eraser like this one here, the ordinary like eraser. This is from Staples. You can see it says Staples on it. This is my daughter's. And you would run it across the track. You like kind of scrape it across the track, and it would clean the track. It would polish it right up. And so if you can see this particular RCA jack, you can tell that it's polishing up rather nicely compared to this one, which hasn't gotten that attention yet. So the deoxit didn't work. And you know, you could look it up on the web. There's all sorts of advice about polishing RCA jacks, but one of the things that they point out is that you don't know what they're made of, and if you use the wrong polishing substance, like a silver polish or something like that, on the RCA jack, you could actually damage this. Ultimately, you know, I think, to be honest, this amp will probably come back, and the reason I say that is because I can't really get inside here with an eraser and polish it, where the tip of the input wire goes into, and the same you know, is true over here on the output. Now, quite frankly, I don't even have to polish the shield of the input, because remember, it's an unshielded wire that goes on this. So this work here of polishing this really doesn't matter. But it was just sort of like a test to see if it would work, right? And because I can't get in there, you know, I'm thinking, boy, whatever oxidization is on these RCA jacks on the shield is probably on the inside, and in fact, probably on the cable as well. And so, you know, what I'm going to try to do here is I'm going to polish them up. I'm going to polish up these RCA jacks, but I'm also going to get to the RCA jacks that are on the underside of the chassis. You know, the cables go from you know, one of these to a connection on the underside of the chassis where it goes into the reverb circuit. I'm going to polish those up as best as I possibly can, and then we'll see what kind of continuity we get out of them. But I'm pretty sure that the continuity is going to be like darn near perfect, right? However, you know, going back to something I said earlier, you see this oxidization on here, and you see it, and then you put that together with the scratchiness of the pots, and there's a little bit of a pattern evolving, right? Essentially continuity problems. So that's something that you know, we have to talk to the owner about, because why would there be such a pattern here? Anyway, so I'm going to take this eraser. I don't know if you can see or not, but I'm just going to start polishing like this And as you can see, it is kind of starting to polish up. You can kind of get that there. This is a great way to polish RCA jacks, and you know that oxidization is coming right off. You could also just use a pencil eraser if you wanted to get in there. And you know, I might have a little bit of difficulty getting under here. That's okay, generally speaking, because we would, you know, as long as you're making some contact, obviously you want to make the best possible contact you can, right? So let's just keep doing this here. There we go, it's getting nice and clean. You know, that's another, you know, going back to an earlier part of the video, we saw where I kind of wrestled a little bit to get the wires off of these jacks. Well, the oxidization that was on there, that was probably the reason, like it was almost fused. Ideally, I think the really long-term fix is to drill out these rivets and replace the entire assembly. You know, resolder, you know, a whole new thing in here. You can even see oxidization on this here. So, you know, there's a real issue there. And that issue, of course, is kind of showing up across the entire amp. Well, anyway, now that I've got these kind of polished up, let's go ahead and throw the multimeter on there and see what we get on those same tests that we ran earlier to check to see whether maybe or not this solves the problem. Okay, before I do the tests on the reverb tank, I just wanted to make sure that I came back to the chassis, because I said that I was going to do some of the same work that I did on the RCA jacks on the reverb tank on the chassis as well. So this is the chassis here, rather nice small compact chassis. I just wanted to point out, I'm not going to make you sit through it, but guess what? Some fairly good oxidization on the RCA jacks here as well. That's the this is the feed going to the input jack on the reverb tank. This is the output, and both of them are pretty filthy. I don't know if you can see that. Try to stay out of the light here, but both of them are fairly well oxidized, and basically what that means is, you know, it was virtually impossible for the signal to get into the reverb tank, let alone get out of it. So we will go ahead and clean these up as well, and we'll see, then we'll get the chassis back into the cabinet, and we'll get it all fired up. One of the things that I'm also going to do is I'm going to get into these tube sockets here. I'll spare you the drama, and we'll get the tubes out and clean up these tube sockets so that you know, any issues in there in terms of any oxidization will be dealt with. And then also one other thing is that I'll throw some deoxit and try to clean up the pots, which are on the other side here. I can kind of flip it over there and you can see the pots right all there. So I got to clean those up too. So that's those are the next steps here, and I'll be back when I have the entire amp back together in one piece and ready to rock and roll. Okay. So we had a little bit of an audio problem with this segment of the video, and I'm re-recording the audio. And here what you see I'm doing is I'm just basically about to recheck the continuity using the same tests that I had found before on the Mesa Boogie website, but I'm going to recheck it with the polished RCA jacks to see if the polishing solved the problem and we can get a good end-to-end continuity from the input to the output. And while it's hard to see exactly what's going on here, the two different RCA jacks, the input is on the
the right side of the screen here, the output on the left, are both polished up. And I've got the multimeter here, and we'll get ready to check it. Also, I polished up the sleeve and tip as best as I possibly could on the leads going from the output and input jacks on the reverb tank to the output and input RCA jacks on the chassis. But one thing to note was that they were actually pretty good already. The tips were pretty good. I was a little fearful that inside the RCA jack where the tip makes contact would be problematic, but as it turns out, it wasn't too bad, which means I may not have to pull the RCA jacks out in the near future. But I cleaned them up anyway. You know, I just cleaned them up as best I could, polished up everything, and then I just go ahead and I plug the leads back in to the tank. And once they're plugged in, we'll set up the multimeter and we'll get the tests going. So let's get those leads hooked up to my multimeter. I'll put the multimeter back here. And got it set to ohms. I'm trying to set it up here so you guys can see it really well. And remember that the first test, I took one lead from the multimeter and I attached that lead to the sleeve of the output wire. We'll call it, so we don't confuse the differences between wire and lead. And then the other lead goes to the tip of the input wire, and in this case we should be seeing some very low resistance. Now the website said 1 ohm, but I'm guessing I've got some resistance in my alligator clip leads. Here we're getting 6.2. That's a hell of a lot better than an open line or 40s, 44 or 45 ohms, whatever I was seeing before. So this test is looking good, and it's also very stable. It's not jumping all around the place. So now we're seeing some really good continuity going from one end of the reverb tank to the other end. And so with that problem solved, we'll go ahead and move the other lead off of the input wire. We'll keep one lead on the sleeve of the output and one lead on the tip. We should see somewhere around 200 ohms, and that is pretty much exactly what we're getting. So now, let's go give this baby a test.
fantastic, man. That is awesome work.
Fantastic. I love hearing that when the owner of an amplifier comes and tries their repaired amp out in the lab here and just realizes that I've brought the amplifier back to life. That's the best feedback I can possibly get, and really glad that he's happy with it. So, along the way, I was noticing a pattern, right? I mentioned this earlier. The corrosion on the RCA jacks, both on the chassis and on the reverb tank. Also, all of the pots were kind of scratchy, sticky. He was complaining that the presence control didn't even work at all, like it just wasn't even changing anything. And I went in there, as you saw, and I cleaned all of the pots really well. I gave him actually like 2 or 3 cleanings each. And I went back to the owner and I said, where was this amp kept? And that's when he said, oh, well, the amp didn't always belong to me. It belonged to a friend of mine, and he lived on the ocean in Nantucket. So that explained everything. This amplifier spent a good part of its life in a house right near the ocean where the air is very salty, and we know just from, the last century of cars and what happens to them when they are near a saltwater environment, how badly they corrode. And in general, all that saltwater air is really going to wreak havoc on anything that's, just even susceptible to corrosion. And of course, those jacks and the pots, all of the metal in there was definitely a little bit corroded, a little bit oxidized. So the cleaning up of those is what solved the problem. I did tell him, though, that this amp may be coming back. For example, I may have to drill out those RCA jack assemblies and put new ones in. The pots may get scratchy because once the metal is compromised like that, it's pretty difficult to really bring it back to brand new. And also, there are clearly some pieces of metal, if you want to call it that, metal surfaces that I just can't get to that easily. So I warned him that the amp might come back, but right now he's incredibly happy with how I brought that amp back to life. So Greg, I hope you're enjoying your amp. Thanks for coming down and jamming in my lab. And for all of those out there who enjoyed this video, please, give it a like, subscribe. I don't make any money on these videos. I don't even make any money on the amp repairs. I just do it for fun, and hope that as I learn and in this journey, that you can join me and learn as well. So thanks very much, and I'll see you at the next amp repair video.